can all hear me, yes? Okay, thank you again for your kind words. And my greetings from Athens, Greece. And my best wishes to Professor Hoda, to all organizers and participants, and to all colleagues and friends. I'm highly honored to be invited to INDIACom-2022 and to be associated with this prestigious conference. And please allow me to say very few words on the topic of energy sustainability, especially in relation to the work of the Research Center of Autonomous Systems at City University. Sustainable development is typically defined as the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And the definition, of course, suggests that we need to balance present consumption of natural resources against those of future generations. This means that we have to sacrifice something today for the benefits of tomorrow. From a technical point of view, this is very common to the idea behind dynamic optimization, which is optimization over time, with many classical results from the fields of optimization, dynamic programming, control, and so on and so forth. So the main idea is a balance between present and the future. I will say very few words about my own background and research interests. This year, after almost 30 years in the United Kingdom, I moved from City, University of London, to the University of Athens in Greece. I'm an electrical engineer by training, and my main research is in the areas of robust and optimal control, risk, and energy sustainability. And here, in robust control, the term robust refers to the fact that we should take seriously the effects of uncertainty arising either in the mathematical model we use, either from the perception of reality that comes from our measurements, and from possibly unpredictable exogenous signals, which are sometimes called disturbances, external disturbances in the control engineering literature. And how all these types of uncertainty affect the evolution of a process over time. Now, if we concentrate to climate change as the main challenge of sustainability today, the targets are fairly challenging. The overall target is climate neutrality by 2050, via intermediate targets of 40% reduction in greenhouse gas emissions from the 1990 levels, a minimum share of 32% for renewable energy, and at least 32.5% improvements in energy efficiency. Achieving all these targets is ambitious and requires increased penetration of renewables in the energy mix and the development of new energy efficient infrastructures. Of course, as recent events indicate, the planned transition to neutrality is not a linear process and can be severely affected by global economic and political events, like the current war in Ukraine. Sustainability policies to achieve climate neutrality by 2050 can only succeed if new technologies emerge, supported by a wide range of computing and IT applications. I have classified them in the following three categories. The first category involves development of modeling and simulation tools, which are capable to handle complex information. This necessitates the use of tools from artificial intelligence and machine learning, big data analytics, data mining, and other similar methods, like neural networks, deep learning, and so on. All these methods represent recent advances in information sciences and require well-designed software platforms for their practical implementation. Let me say very few words on some of the modeling work that we carried out in the City Group. in the group at City University. This includes the development of a multi-period energy mix optimization model with terminal constraints set to the 2050 net zero emission targets. In this approach, energy planning is formulated as a portfolio investment optimization problem under constraints of cost and risk. Risk may be either economic or financial in nature. For example, it can represent uncertain future costs of renewable technology, or another source is that it could also arise, for example, from over-reliance on a specific energy source or on a particular technology. Our approach in the work at City University is based on the formulation and solution of a dynamic programming optimization problem over time. An advantage of this approach is that it allows corrective action to be taken if intermediate targets are not met, for example, due to unexpected economic or political events. The work is motivated by model predictive control and is capable to self-adapt the optimal policies in real time as uncertainty is progressively revealed. And the approach is inspired by portfolio rebalancing and financial engineering. Okay, let me move on to the second area of application, which involves design for energy efficiency. And this typically requires the extensive use of embedded sensors and the application of advanced information and communication technologies. The work at Citigroup has concentrated in this area through two European EU-funded projects in district heating and cooling. Now, this type of systems distribute heat, which is generated at a centralized location, for example, a cogeneration plant, to residential and commercial buildings in a neighborhood through a network of insulated pipes. In the new generation district heating systems, which are currently under investigation, information technology will be of vital importance. Their operation will rely on a central energy management system supported by advanced algorithms which forecast future energy demands and optimize heat production. A final category of applications is the smart grid and smart technologies. The smart grids are complex cyber-physical systems that rely on intelligent monitoring, control, and communication technologies. IT applications in this area include smart metering, data modeling, sensor fusion, big data analytics, security and privacy, blockchain and energy trading, and many others. Being online, a smart grid is vulnerable to cyber attacks and needs to be protected by cybersecurity software, which adds another layer of complexity to applications. Let me conclude by saying that computing and information technology are indispensable to the success of energy sustainability policies. And apart from the technical solution that they provide, they also demonstrate to people that there are alternatives to the present development model, which are both feasible and practical. Okay, that's all I have to say. I tried to make it a short introduction. Thank you again very much for your attention, and I'm looking forward to a successful and productive INDIACom-2022 conference. Thank you very much.
More time.